Good morning students. In this video we can construct Turing machine for subtraction of two numbers. So that is design a Turing machine to perform subtraction of two non-negative integers. Those are x and y. So represent this Turing machine with its transition diagram and transition table. So while we will go for performing the proper subtraction, so we can use these two functions, that is f of x comma y is equals to x minus y if x greater than or equal to 4. Another one is f of x comma y equals to 0 if x less than or equal to 4. So that means, so here first condition or first function is f of x comma y is equals to x minus y if x greater than or equals to 4. So that means let x equals to either 4 and y equals to either 2. So then the subtraction is x minus y. So that means 2. So in case, and second function is f of x comma y is equals to 0 if x is less than or equals to y. So that means, so let x equals to 2 and y equals to 3, then their subtraction x minus y is equals to 0. So why? Because here x value is the smaller value to compare y value, so that's why obviously the subtraction is 0. So these are the two functions to perform the to calculate the subtraction of two non-negative integers. So for this we consider that let x equals to 3 and y equals to 2. So then what is the input tape representation? So here these two values, x value and y value, can be represented in Turing machine as unary numbers, So that means x can be written as 3 ones and y can be written as 2 ones. So that is nothing but, and these two values can be separated with some separator or delimiter. So that is input tape representation can be 1, 2, 3 ones and some separator or delimiter symbol, and y value is 2 ones and ending with either blank space or del space. So this is the representation of our considered input in Turing machine input tape. So here we assume the separator or delimiter is minus, otherwise either 0. Just assume a separator or delimiter is 0. So here end of the input tape is, which may be blank or del also. So blank or del also consider, that is our choice. So here to calculate subtraction of these two numbers, so first we consider whatever the value from x. So this one and this one can be balanced. That means this one can be marked as empty. So that means remove from the input tape. That means it can be treated as del, and this one also treated as del. So in between, whenever first one can be read as input and converted as capital del, and move right. So move right. So in this process we can read any number of ones and 0 and 1. Then we can skip these all input symbols. We can reach end of the input tape, that is del. So up to del. So whenever we are reaching the del, then move left, and immediate one can be converted as del. That means this one can be removed from the input tape, and then move left up to this del and consider second one, and this one also converted as del, and move right up to end of the input, that is del, and move left, second one can be considered or converted as del. So in this manner we can performing the subtraction. So that means from input tape, from initial state, when read first input as 1, so this one can be converted as del and move right. So this is input and this is the external symbol. That means this one can be converted as whatever the symbol, and this one indicates direction of the header, and then go to next state. So this one is completed. Next we can skip any number of ones and zeros. We should not perform any operation, so simply move right. So that's why we consider loop. When read 1, no change, that means no operation, as it is, and move right. So after first one, going to same state q1. So again read second one, going to the self, same, without any change. Next we read 0. So this 0 is also skipped. So that's why 0, no change, and right. So 0 can be not marked as any external symbol, and then move right. Next again 1 occur. So 1 can be converted, not converted as anything, and move right. Again 1. So not converted as anything, and then move right. So next end of the input, that is del. So now this del can be not changed as anything, and then move left. So now going to q2. So now this one can be converted as blank symbol, that is del, and then move left. So that's why this one can be converted as del, that which indicates blank symbol, and then move left up to del. So move left. So in this process, so this one can be converted as del and then move left. So in this process we can read any number of ones and zeros. That's why any number of ones, no change, left. Any number of zeros, no change, left. So we reach up to end of the left end of the input, that is del, or previously marked del. So that's when we read this del, move right. So that's why when read del as input, here this one, when read del as input, no change, and then move right. So now this one can be marked as del and move right. So that's why one can be converted as del and then move right. Next, and then go to next state q1. So now we read either 1, no change, right, either 0, no change, right, again 1, no change, right. When we read del as input, no change, move left, and then this one can be converted as del and then left. So now this one can be converted as del and then move left. Next going next state. So now this 0 can be as it is and then move left, and this one can be as it is and then move left. So now del. So del r. So that means this del can be converted as del and then move right. So now this one can be converted as a del, this one can be converted as a del and then move right. And next 0 can be leaved as it is, that means we should not perform any operation, and then move right. But after we are expecting 1 actually, but here that is del. So 0 immediately we are getting del. So and then move left. So after 0 immediately del and then move left. So now there was no ones to perform the marking. So that's why from here when we are moving left, so there was no ones to perform the mark as some external symbol. So that's why, so after del immediately the symbol is 0. So that's why when we are moving left from this del, when we are moving left, next immediate symbol is 0. So that's why when read 0 from q2, actually from q2 we are expecting 1 as input symbol and converted as capital del and then move left, but here the input symbol is 0. So that's why this 0 can be converted as 1 and then move left or right any direction, and then move left or right any direction, and then go to accept, So that means till now what happened, so this one can be converted as del and then move right. So here after 0 there was no 1, so that's why this 0 can be converted as 1. So that means finally input tape contains whatever that input del 1 del. So that means the result is 1. So this is the answer. Next, so this is the first function. So x greater than or equals to y. Sorry, x greater than y. Okay, right. So now we consider second case, that is x less than or equal to y, then it returns 0. So that means we assume x value is 2 and y value is 3. So then we follow the same process. So that means this one can be converted as del and move right. Next, this one can be converted as del and move left. This one can be converted as del and move right. So now this one can be converted as del and move left. So now this 0 as it is, and then move end of the tape. So that means this export is completed. So these all symbols can be blanked. So that means removed from the input tape. Then the result is 0. So then the result is 0. So that's why when we are moving right, this 0 is as it is, and remaining ones can be converted as dels and then move right. So that's why from Q0. So that means after completion of this one. So first, so we are reading 1 from the initial state and converted as del. So this one can be converted as del and then move right. Next, this one skip. So that's why 1 1 R. Next 0 is also skipped. We should not perform any operation. That's why 0 0 R. And next 1. So no operation. That's why 1 1 R. Same up to end of the input tape. So that means del comma left. So this one. So now we are moving left. Now this one can be converted as del. That's why this one can be converted as del and then move left. Whenever we are moving left, after converting this one as del, we are reading any number of ones and single 0 and ones. That's why we can perform the loop. So any number of ones, no change, left. 0, no change, left. After that del. So this del. So del as it is and then move right. So now we are actually expecting 1, but here the input is 0. So that's why this 0 is as it is. 0 is as it is and then move right. So here x portion is already completed. That's why remaining y, whatever the values contained by the y, those all are converted as empty symbols or blank symbols. That's why these ones can be converted as del and then move right. So after completion of ones, del is the input, del comma R. So and then going to halt. So now finally input tape contains whatever the input. So here 0 0 R from Q0. When read this 0, no change and move right. Next, when read 1, converted as del and move right. And next del is the input. That's why going to halt. That means accept. So finally what is the value in input tape? Del 0 del. So result is 0. So this is the Turing machine for constructing subtraction of any two non-negative integers. So now we construct transition table for this Turing machine, and then so now we construct transition table for this Turing machine. So whatever these states, and then whatever the input symbol, yes. So whatever the several input symbols, and then end of the tape. So here the input symbols is either 1 or 0, and rare cases we can consider blank is also as input symbol. So these are the inputs, 1 0 and blank. So here totally we are containing in transition diagram Q0 1 2 3 4 states and halt also. Q0, Q1, Q2, Q3, Q4 and halt. So now from Q0, when read 1 as input going to Q1, so that's why next state is Q1 and external symbol is del and direction is right. From Q0, when read 0, so this one, when read 0, next state is Q4, external symbol is nothing and move right. And from Q0 there was no need to reading del as input. So these are the transitions for Q0. Next Q1. From Q1 we can read three symbols. When read 1, no change, sorry, going to the next state Q2 and external symbol is 1 and direction is right. When read 0, going to, so when read from Q1, when read 1 as input going to same state, external symbol is same and right. So that's why Q1 1 comma R. So when read 0 is also same, Q1 0 comma R. When read del going to the Q2 and external symbol is del and direction is left. Next. From Q2, possible input symbols is 2, 0 and 1. So from Q2, when read 0, from Q2, when read 0, going to halt. So when read 0, going to halt, external symbol is 1 comma right. Halt 1 comma direction is right. And Q2, when read 1, going to Q3, going to Q3, external symbol is del and direction is left. That's it. So here there was no input for del from Q2. So these are the two inputs possible from Q2. From Q3, 3 inputs, 0 possible, 1 possible, del possible. So when read 1 going to Q0, external symbol is 1 and direction is left. When read 0, sorry, when read 1 going to Q3 itself, going to Q3, external symbol is 1 and left. When read 0 going to Q3, external symbol is 0 and direction is left. When read del as input going to Q0, external symbol is del and direction is right. Direction is right. Next, from Q4. So two possible input symbols from Q4. One is 1, another one is del. So that's why from Q4, when read 1 going to self. So that's why Q4 external symbol is del and direction is right. When read del going to halt and external symbol is del and right. So on 0 no transition. From this state halt, so no transitions, that's why leave it. So this is the transition table for Turing machine constructed subtraction of two numbers. So these are the details. So we are constructing transition diagram for Turing machine which represents subtraction of two numbers which satisfies the two functions f of x comma y is equals to x minus y if x less than y, so x greater than y. At the same way f of x comma y equals to 0 if x less than or equal to y. So this is the transition diagram and this is the transition table. So now we perform some simulation. So that means we consider some example, some input string, and then So now we consider some input string and then how our Turing machine was properly performing the subtraction or not. So for that purpose, first one, x equals to 4 and y equals to 2. So this is the first case. So this, it can be represented as input tape as, it can be represented in input tape as 1 2 3 4 ones, and separator is 0 and y value is 2 and ending value is del. End of the input tape is del. So this is the input tape. So now we check this particular input can be simulated through our Turing machine and check what is the result. So we are starting from Q0. From Q0, when read 1, this one can be converted as del and then move right. So this one can be converted as del. So remaining is 1 1 0 1 1 del and direction is right. So go to next state is Q1. Sorry. So consider Q0 is the current state. Total input is 1 1 1 0 1 1 del. This one. So now from our Turing machine, from Q0 input is 1. So this one converted as del and move right. So that's why move right and go to Q1. So that's why next one is Q1 is the next state and current state. So this one is converted as a del and remaining is 1 1 0 1 1 del. So now header is here. So now simply move right from Q1. When read 1, no change, move right. So that is Q1 comma del 1 1 0 1 1 del. So here also move right. So until del we can perform the move right. So that's why del of Q1 comma del 1 1 0 1 1 del, move right. So del of Q1 del 1 1 0 1 1 del, move right. So del of Q1 comma del 1 1 0 1 1 del. So say move right up to del, move right up to del. So del of Q1 comma del 1 1 0 1 1 del. So now move left. Del of Q1 comma del 1 1 0 1 1 del. So now header is here. So now check from Q1, input is del and move left and going to next state Q2. So here next state is Q2. So now current state is Q2, input is 1. So that's why converted as del and move left. So 1 convert as del and move left up to where? Up to del. So that's why now del of and then go to Q3. So move left and then go to Q2 here. So now here, so 1 can be converted as del, move left and go to next state Q3. So that's why next state is Q3 del 1 1 0 1 del del. So now move left up to del. So that's why header is here, move left del Q3 del 1 1 0 1 del del, move left del Q3 del 1 1 0 1 del del, move left. Why? Because header is here. So Q del of Q3 comma del 1 1 0 1 del, header is here, move left. Del of Q3 comma del 1 1 0 1 del. So header is at del. So now check out from Q3, head input is del, then external symbol is del, and then move right. So that's why, so move right. So previously we perform this one. So current state is Q3, input is del, so that's why move right and go to Q0. So that means input is del from Q3 state, so input is del, so external symbol is same, no change, and move right and go to Q0. So that's why we are at Q0, input is del 1101 del. So now we are at Q0, input is 1, so that's why 1 can be marked as del and move right up to where, end of the tape, del. So that's why del off and then go to next state Q1. So Q1 del, this one can be converted as del and move right, so that's why header is here 0 1 del. So now we are at Q1, input is 1, so that's why move right. So del off Q1 del 1 0, header is here 1 del. So current state is Q1, input is 0, current state is Q1, input is 0, so move right, no change. Next, del off Q1 del 101 del. So current state is Q1, input is 1, so move right. So del off Q1 comma del 101 del. So now current state is Q1, input is del, so that's why move left. So move left. So del off and go to next state Q2. So Q2 del 101 del. So now current state is Q2, input is 1, so that's why this one can be converted as del and move left. So this one can be converted as convert as del and move left up to del. So that's why del off, and next state is Q3. So Q3 del, this del can, any number of dels means same, so that's why skip it. Del 1 0, this one can be converted as del and move left, so that's why header is here. So now we are at Q3, input is 0, so no change, move left. Del off Q3 comma del 1 0 del. So state is Q3, input is 1, so no change and move left. Del off Q3 comma del 1 0 del. So now input is del, current state is Q3, so move right and go to Q0. So del off Q0 comma del 1 0 del. So current state is Q0, input is 1, so that's why 1 can be converted as del and move right. So 1 convert as del and move right. So del off Q1 and comma next state is Q1 comma del 0 del. So we are at Q1, input is 0, so move right. So del off and then go to same state Q1 comma del 0 del. So current state is Q1, input is del, so that's why left, move left and go to Q2. So now current state is Q2 del 0 del, so header is here, move left, that's why header is here. So from Q2 input is 0, then convert as 1 and move right comma halt. Convert as 1, move right and halt. So from here, so Q2 input is 0, convert as 1, move right, halt. So that means del of q2 comma del 1 del and then halt. So here we are missing one more one, 4 ones. That means 1 1 1 1 1 4 ones. The x value is 4, that's why 1 1 1 1 1 1 1. So now this 0 can be converted as 1 and then halt. So finally the input tape contains del 1 1 del, so that is the result is 2. So x value is 4 and y value is 2, then x minus y is nothing but 2. So this is the answer. This is the process of performing the simulation. So thank you.